Hey, it's Ryan with MOS Equipment. Previously, we built this mill standard shielded Faraday box, including TitanRF Faraday Fabric, TitanRF tape, TitanRF gaskets on the inside. That's in our previous video. Click the link to find that. Now we're going to show what it takes to install a shielded vent inside of the box. You may want to do this for different purposes. You may have equipment that you're trying to shield that needs to be vented to have airflow. You may be building a larger enclosure for wireless testing that humans may go inside of. There's a lot of reasons why you may want to pass air back and forth from a shielded enclosure and out, and this is the way to do it. These shielded vents can be found on our website, mosequipment.com. The way to install them is pretty simple, but there's always a lot of confusion on exactly how to do it, so we're going to show you that today. The first thing that I did ahead of time is I measured the opening of this vent, which is about 10 1/8 by about 4 1/8. So you can see that here. This is what you want to measure, the perimeter, because this is going to be inserted through the enclosure, and then this area here is going to make contact with the shielded materials in the room, okay? So those shielded materials are inside the box. I pre-cut the hole. You can see that it's the size of the perimeter of the actual vent. And I didn't mention, this is a honeycomb. It's called a honeycomb shielded vent. So you can see the honeycomb shape here. Even though this passes air through, it is going to block RF signals from low megahertz up to 5 gigahertz and even above. It's really effective in signal blocking. But what I did is I pre-cut this hole a bit rough. It's not the cleanest. I was using a reciprocating saw. You probably would want to use a jigsaw. And then I'm gonna shift this around to see on the inside here. The fabric was cut. I did drill holes in the corners to make it easier to cut through to the corners, and those holes went through the Faraday fabric. And then I went ahead and cut the Faraday fabric inside before I cut the plywood on the outside. That's gonna make sure that the fabric doesn't get stuck in your saw and rip. It's just gonna make a cleaner cut. This is 2 layers here. The vent is gonna go from the inside to out, so that flange on the vent right here ends up making contact with the shielding fabric on the inside. But before I do that, I'm going to add a gasket, and these come with the vents. These gaskets just help make sure that good contact is made from the vent flange onto the Faraday fabric. And to do that, these gaskets are supplied, but I'm just going to be using a little TitanRF Faraday tape right here to adhere it. It'll make it easier if I add the gaskets onto the actual vent before I install the vent. The other option is to try to work them on while you're installing it, but they can just fall off and it becomes a little bit of a hassle to do that. So I'm just going to cut a couple small pieces that will let me attach the gaskets together. So just move this aside so you can see it. And because this tape is shielded, it's going to maintain conductivity when I apply these gaskets here. The conductivity will work through the gaskets onto the tape, and you don't want too much tape because it may affect how the gaskets actually compress. So I'm just going to add a piece right here. What you really want is for this inner sort of cushion compressible part to be as tight into the gasket as possible. That just helps maintain conductivity when I put the screws through to it. A piece of tape here. Okay, so I have the gasket here. It doesn't need to be perfect. It's going to compress, but you do want it tight around as much as possible. And I do want to mention, so a lot of applications you include 2 vents. So you may have a vent that's down low where air is being pushed in, maybe from a fan that's connected on this side. You could use a computer fan or a larger fan with a tube to push air. And then you may have a larger or a same size vent up top to allow hot air to escape. That's a common application. So I'm going to keep this seated on here and then push the vent in through the hole, just leaving it out a little bit to show it like this, right there. And my hole is a little bit, it's not very, it's a little bit tight for the vent. So actually that worked pretty well. I'm just gonna compress it. And you can see here that the gaskets extend out a little bit. That's okay, they're meant to do that. That helps even. So I'll push it in all the way and then turn the box to show right here how it's extending outward. And you'll notice there's no shielding materials on the outside because it's not necessary. All of the conductivity is maintained on the inside. So it's just sticking out of here. It's not a problem. And then the final step would be to take some screws. In this case, we're just going to use self-drilling. These are actually sheet metal screws, but they're fine for this application. You can use any screws. Just make sure that when you put them in, they grab the vent adequately and push it against the material. There's no particular order that you need to install the screws. You don't need to follow what I did. Just kind of try to get it in there seated really evenly, and it compresses that gasket. We do supply some screws and nuts with these. If you're applying it to metal or installing it in metal, sheet metal or anything like that, just drill all the way through and get a really tight fit. You want the flange and the gasket compressed really tightly against the metal. I'm going to go ahead and test it now. So we are close to our Wi-Fi router. So I'm going to test Wi-Fi. I'll just do that test. We have videos showing both cell and Wi-Fi, but I'm going to look for Faraday test. Okay. Now I'm just going to click start. You'll see that I have a Wi-Fi signal, and it's pretty strong. I have the bars up here. I'm right next to the router. The router's a pretty high-powered router. I'm going to set it inside, close the lid, and latch it to compress all of the gaskets. And what I want to see is immediate signal loss. A bad sign is if the Wi-Fi breaks off and cuts and then comes back, cuts again and fluctuates. That means we have leakage in there. Obviously, if it doesn't cut off at all, that means it's not working. And here we go. Click stop test. I've got green check marks. About 15-20 seconds in, which is when I latched it, when I got this in there, it cut off completely. This is great. That's what you want to see. And then you could turn your Wi-Fi on to 2.4G if you have both 2.4 and 5, just to test that, and then turn your Wi-Fi off to test cell. So that's it. This is installing a shielded honeycomb vent into our mill standard Faraday box here that we constructed. If you have any questions, as always, feel free to contact us at info@mosequipment.com. And these shielded honeycomb vents can be found on our website. Thanks for watching.